Alright guys, we are back. We just got done looking at the periodic tables and families, etc. So we're looking at bonding and getting into ionic compound nomenclature for this video. So the first thing I just want to make sure we see is some basic definitions. You have chemical bond, which is basically what's just holding the two elements together. This chemical bond is formed from the attraction of electrons of one element to the protons of another element, or atoms I should say. So that's how they're being held together. There's two types of bonds that we focus on, which is ionic compounds, which is where the electrons are transferred. This transfer is what we saw with the charges on the last video with the elements, certain families having specific charges. The alkali metals have a +1 charge. That means they transfer one electron to another element, and the halogens have a -1 charge, which means they accept that electron that was transferred. Covalent bonds, the electrons are shared in this case and not transferred, meaning there's no charges here. They're just straight, simple elements sharing electrons. Okay? Either way we look at this, everything is based off of the, sorry about that, everything is based off of the valence electrons and nothing else. Okay, so looking at naming, when I want to pick two elements, or actually this is just making the chemical formulas, making sure we remember how to do this. This is all about charges. So let's just pick two random elements. Let's say we are picking magnesium, okay, and let's say chlorine. Okay, well if we go and look at our periodic table, magnesium is in the second group, in the alkaline earth, so it's a +2 charge. Chlorine is a halogen, it's a -1 charge. So what we see here is two different charges. We have a +2 and a -1. Now, all compounds have to be neutral, meaning their charges have to add up to equal 0. Well, one magnesium plus one chlorine is not going to equal 0. But if we had two chlorines, we would have -2, one magnesium plus 2. They would cancel out. What we can do, though, instead of trying to look at the math, is the cross and swap method, which means this number is going to come down here, and this number is going to come down here. So we end up with a compound, Mg1, and we don't ever show the 1, Cl2, and we have the 2 there. Same can be done with just about anything else. Let's say we have aluminum, okay, and let's say we're combining aluminum with oxygen. Okay, well, aluminum is group 3, so +3. Oxygen is 1 over from fluorine, so -2. Again, cross and swap, meaning the 2 is going to come down, and the 3 is going to come down. So we have Al2O3. Notice that the state of the charge is not coming down, the -2 or the +3, because once they're down here, they're counting numbers. They are always positive, so we don't ever have to show that. Up high, they are charges, so they will either be negative or positive, but down below they're counting number, which are always positive. So just again to see another one, let's say we have potassium, okay, which is an alkali metal, so +1, and let's say we are combining that with, let's do sulfur, which again is a -2. Actually, let me see if I can get this to work. Instead of sulfur, let's do nitrogen. Oh, it stopped writing. Hold on, guys. Give me a second. There we go. Nitrogen's a -3. Sorry, Smartboard is having a little bit of a mild problem this morning. All right, but again, we bring down our 1, bring down our 3, and we end up with K3 in 1. Again, we don't show that 1. So that's kind of your cross and swap. And hopefully you remember that vaguely. Now with naming, it's just as simple. Let's say we have that compound we had the first one. Do I go back and grab the first one? It was MgCl2. Okay, so the first thing we're going to do is name the metal. Okay, the second thing we do is we name the non-metal. And in the process of naming the nonmetal, we have to change the ending to IDE. So what this means, Mg is magnesium, so our name is magnesium. Okay, Cl is chlorine because we're changing the ending to ID. We end up with chloride. Okay, same can be done with Al2O3. Again, aluminum is our metal, so we just name it. Okay, and then O is oxygen, it becomes oxide. K, potassium. Okay, and N, nitrogen, so nitrite. So that's kind of our simple naming. Now things do get a little bit more complicated than that. Let's go back and look at transition metals. We haven't really looked at anything transition metals. If we remember with transition metals, if I go back and show you that periodic table, which is way, way, way back here, there it is. Okay, remember this D block right here does not necessarily have charges consistent with valence electrons because they are inner electrons. They can kind of vary, and they do vary pretty significantly. You have iron that could be +2 or +3. You have copper, which is +2 or +1. And you have some of these, like molybdenum and a couple of these other ones down there that can have upwards of 4 or 5 different charges. It just depends on the metal that we're looking at. You do not need to have these charges memorized. You just need to know how to be able to utilize them. So let's go back and look at one. Let's say we are looking at FeO. Okay, well actually let's save that one. Let's say we're looking at Fe2O3. Well, if we remember correctly, these numbers, okay, came from the charges, which means they came from up here at some point in time, and we'll deal with that in just a minute. When we're naming these, we're again going to name the metal Oops, there we go. Name the metal, but we're going to identify the charge. And we're going to identify the charge with Roman numerals. Okay, so just Rn is Roman numerals. I'm doing shorthand just for right now. The second one we do is we name the nonmetal just like we did last time. And of course we have our IDE ending. So here we've got iron and oxygen. So we first want to just kind of go, okay, this is iron oxide. Pretty easy. But we need to identify the metal's charge. And the way we do that again is Roman numerals. I typically do them in parentheses. You may see them outside of parentheses. It just depends on who's writing them. And the way we get this number that goes in the parentheses is by uncrossing and unswapping. Well, the 2 comes up to oxygen, which means oxygen was a -2. Remember, the anion, or the second element in the compound, is always negative. The cation, which is the first element, is always positive. And the 3 comes up to iron, which that means iron is a +3 charge. So what we end up naming here is iron 3 oxide. Okay, let's look at another one. Let's say we have CoCl2. Okay, well, Co is cobalt. Okay, Cl is chlorine, so chloride. Okay, again, we have our parentheses for our Roman numerals. We bring up the original numbers that were here, so the 1 and the 2 means chlorine is a -1 and cobalt is a 2. So we end up with cobalt 2 chloride. Okay, and the other example I was just kind of showing you was, let's say we have iron and oxygen, FeO. Okay, well this one can be a little bit problematic. We know it's iron oxide, but what's its charge? There's no numbers down here to bring up. Well, so what that basically means is that both of these numbers down here are 1. So if I bring a 1 up to iron and a 1 up to oxygen, I would be looking at Fe +1 and O -1. Well, we have a little problem here. Oxygen is not a -1 charge. It's actually a -2 charge. So that means if a -1 is actually a -2, +1 must be a +2. They are proportional, so they're basically ratios. If this is +1, this is -1. If this is +2, this is -2. These two are the same numbers, so they simplified to have basically 1s down here, if we remember that. So this is going to be iron 2 oxide versus iron 3 oxide. So that is naming transition metals, ionic compounds with transition metals. And the last one we're going to look at is naming ionic compounds with polyatomics. Remember, you got a list of polyatomic ions last year. You're going to get another one, and just to kind of refresh us what polyatomic ions is. We have NO3, which is nitrate. And I'm just going to kind of throw some up here so we kind of remember seeing them. SO4, and that is a capital O. I know it doesn't look like it. -2. Sulfate. Okay, let's say we have BrO3 is bromate. Okay, etc. These are our polyatomic ions that we're going to be using. So let's say we have CaNO3. Okay, and actually should be CaNO3 too. Remember, with these, we're still going to name the metal. If it's a transition metal, you're going to show the Roman charge, or the Roman numeral as a charge. And if it's a polyatomic ion, you still just name it. And 2, we just name the polyatomic ion exactly like it is. We don't change it. So here we have calcium. Calcium is not a transition metal. Remember, it's not in the D block, so we don't need Roman numerals, so we can just leave it as is, no parentheses. NO3 is nitrate. So this is calcium. Whoops. Let's try that again. There we go, calcium nitrate. Okay, let's say we have another one. Let's say we are looking at something like that. So VSO43, and again, notice that I have the parentheses around both of these. The parentheses is just if you have multiple of them. Hopefully you remember that vaguely. If you need help, let me know. V is vanadium. Okay, and again, this is a transition metal, so we have to get our charge, and it is a 3 here. Whoops, sorry, 3, and then sulfate, SO4. There we go. All right, and that's kind of how these work. They're pretty straightforward. You may have some that end up being like something like this. Oh, that's an O. Let me try that again. Sorry, guys. Let's say we have CO3. Well, that's cobalt and carbonate. CO3 is carbonate. Cobalt's a transition metal. Carbonate's a polyatomic ion. We need the charge for cobalt. So we have cobalt, parentheses, and then carbonate. Well, again, we need to uncross and unswap. However, this 3 belongs with carbonate. It has nothing to do with the transition metal. It's not a charge. So again, if you put parentheses around it here just to see it, there's no number out here or here, which means both of them are 1s. So that means you have CO plus 1 and CO3 minus 1. However, if you look on a polyatomic ion list, carbonate should be minus 2, which means cobalt should be plus 2, which means your Roman numeral here is 2. So cobalt 2 carbonate. All right, so that's kind of the quick and painless, I guess, if you will, ionic compound naming review. Again, if you need help, you know where I am. And that's it. Let's look at covalent compounds next.